So with this lecture, we are going to convert using different units related to the mole. So we'll be using concepts of dimensional analysis unit conversions, as well as what is a mole. Now here's some key concepts that we'll be going through. Essentially today is a lot about math. It's a lot about conversions. So you do need to be able to explain the relationship between the mole and then these following measurements: mass, particles or atoms, and then volume. Now explaining that relationship can be a written out answer. It may also take the form of calculations. Now to help conceptualize the relationship between these concepts, we have this, which is a mole calculator. Now mole calculator maybe, also I sometimes have heard it and will use it described as the mole highway. It's kind of a road map. Essentially, you're going to be starting at a certain place on here. So like you might start with mass. That means you're given some measurement in units of grams. And then you're going to be asked to calculate some other unit. So like if you got some amount of mass, how many moles is that? Or if you've got some amount of mass, how many particles is it? So as long as you follow the conversion path, you'll be okay. Every arrow that you see represents a conversion. And I'm going to take a moment to fill this in. What you should do is write this down as we go. And also, this mole calculator, just to make it as easy as possible to read, I would recommend making that about half sheet of paper from top to bottom. So take a moment, write down what you see here, and then there's going to be a lot more coming up. So first, the relationship between mass and moles. We've looked at this in class. It's the molar mass. Now this is specific to every substance. So you need to look at the periodic table. You need to know what the substance is. If it's a compound, you need to add it all up together. Now that's going back and forth. So this is an equal sign. So how you're going to be using a conversion fraction. However you set it up determines which units you need to cancel. And we'll be doing lots of practice with this. The next pathway is one of the more common ones, between moles and numbers of particles. So rather than mass asking how much, particles is asking the question how many. And so the equality there is 6.02 times 10 to the 23rd particles equals 1 mole. Using the other unit, volume, or the other measurement, we're going to go into some more detail on this one. 22.4 liters equals 1 mole. Now that's for a gas at standard temperature and pressure, and I'll be talking about that a little later in this lecture. Now on this side, something to note, between volume and moles, and then also between moles and particles, this value does not change. So these numbers are going to be the same. It does not matter what the substance is. These two numbers are constant. And that's a little different on this side of the period, or on this side of the calculator. Like over here with molar mass, that changes for the substance. So you need to know what the substance is. Also, this little step. Sometimes we'll need it, sometimes we won't. The time that we'll need it is if the question asks for how many atoms there are in some number of moles of a compound. So something like, say, CO2. The particle is CO2, that's the molecule, but each molecule has, say, 3 atoms, because it's CO2. So then it would be 3 atoms equals 1 particle. Again, this step is only necessary if you're asked for atoms of a compound. And again, for these two, that number changes for the substance. So make sure before you move on that you got this written down and you maybe can see some of the relationships between the two. So first sample problem, mole conversions. We're going to go between moles and mass. So here's the question. How many grams of lithium are in 3.50 moles of lithium? So how many grams? That means that's your ending point. You're going to end here at mass. You're given 3.50 moles of lithium. So the substance is the same. You're starting here on the mole calculator. So this is just kind of an isolated version. You're going from here to here. One thing to note, you're going to be using molar mass. Since this is asking about mass, you don't need Avogadro's number, 6.02 times 10 to the 23rd. Many students often think you always need to use that number, and you don't. If you're dealing with mass, and only mass and moles, you don't need Avogadro's number. So Again, this is going to be a conversion. We're dealing with lithium, and that's the molar mass right there. So we set up a conversion. Start with the number and unit you're given, 3.50 moles of lithium. Setting up your conversion fraction and knowing that you need to get to grams, you've got to cancel moles, and grams goes on top. This number here, 6.94, comes from the periodic table rounded to the hundredths place. You're going to cancel moles because you got moles on top and moles on the bottom. To get to a final answer, you multiply across the numerator and then you divide what's in the denominator. So in this case, your answer is going to be 24.3 grams of lithium. And that's it. That's really it for the answer. So you're given moles, and what's the mass? All you need to use is molar mass. So that's going along that pathway. This next problem is going to be the same in a sense, but we're just going in a different direction. So notice that you're given grams, and you need to convert to moles. What I recommend that you do here is pause the video and go ahead and set it up and do the calculation. Okay, so hopefully we are good to go here. You start with the number in the problem, including the unit and the substance. We're going to be using lithium, which is the molar mass. So that's going to now cancel on the bottom so that the grams cancel. Moles is going to be the unit on top. That's the one we're trying to get to. So you cancel out those units. 18.2 divided by 6.94 gives you 2.62. So that's going in the mass and mole direction. So that's a one-step conversion just between the two. Looking at sample problem number 3, here's the question. How many atoms of lithium are in 3.50 moles of lithium? So you're starting here, and you're asked to get to atoms. Now, you're going to be using Avogadro's number. You can set up a conversion. Now this little detail here, there's going to be something that comes up at some point here, that this step is only necessary if you're dealing with a compound. In this case, it asks you for atoms of a single element. So one particle of lithium, well, is an atom. So it's like a 1-to-1, so you don't have to show this step. It's only necessary for compounds. So, starting with the number in the problem, you could take it from here if you feel ready, but I'll talk through it. Trying to get to atoms, canceling out 1 mole. Now what is equal to mole between these two? It's going to be Avogadro's number, 6.02 times 10 to the 23rd atoms. Units cancel, moles do. Atoms is the unit we want in our answer, which is all set up. Multiplying across the top, it'd be 3.50 times 6.02 times 10 to the 23rd. And if you get all that straightened out, this should be your answer. A common mistake that students make is forgetting the times 10 to the 23rd and just doing 3.5 times 6.02. It often gets left out, so just make sure if it's there and doesn't cancel, you have to include it. Now in this case, simplifying to proper scientific notation gives you this answer. Sample problem number 4 is going to be along the same pathway, moles to particles. Or particles to moles. Here's the question. This one, in fact, though, is a 2-step conversion. And here's how. Asked how many atoms, so that's here, atoms of lithium, and you're given 18.2 grams, which means you're starting here. So notice there's no direct line from mass to particles, so you got to follow the pathway. Go from mass to moles, that'd be one conversion, and then moles to particles, that's the second conversion. So it is going to be multi-step here. So those are all the equalities that we're going to need from our mole calculator. And we set it up. If you feel ready, pause the video, get to it yourself. If not, I'll be explaining it right here. Start with the number in the problem, 18.2 grams of lithium. Going from there, canceling grams, converting to moles first. So this is the first step across this pathway that you can see me highlighting. Now that grams have canceled, the unit we have is moles. But that's not where we want to be yet, canceling grams. We need to get to atoms, or particles in this case. So canceling moles. And then we have 6.02 times 10 to the 23rd atoms per mole. Now dealing with the math. You got to multiply what's across the numerator, divide by what's in the denominator. And you can simplify this. And what you should end up with is 1.58 times 10 to the 24th atoms of lithium. Again, this two-step problem is necessary because you started with grams and you had to get to particles. So you have to go through the mole. Okay, next one here, standard molar volume. This is maybe a new one we haven't talked about yet. And here is a scientific law that was determined by Avogadro, that equal volumes of a gas at the same temperature and pressure is going to have the same number of molecules. Now this is kind of a big one. What this means is that if I have a balloon, and the balloon, if I have like three, and the balloons are the same size, and one of them is carbon dioxide, one of them is just like air, and one of them is, say, nitrogen. They're the same size, same temperature, same pressure. All of those balloons would have the same number of molecules. Doesn't matter what the identity is. So what that means is that we can actually come up with a molar volume. So if we counted up 6.02 times 10 to the 23rd, put them into a setting, we could figure out the volume. And so here it is. At what we call standard temperature and pressure, which we'll learn about a bit later, 1 mole of any gas. So if we counted up 6.02 times 10 to the 23rd gas particles, put them into a balloon, they would occupy 22.4 liters. So that gives us this equality. 1 mole equals 22.4 liters. Now this, again, it's important to note, this only applies to gases at standard temperature and pressure. Gases can change if the temperature and pressure changes, but it's in this one narrow set of circumstances. But we're going to be using it. 1 mole equals 22.4 liters. So, as a sample problem here, it's asking how many moles of hydrogen are in 100 liters of hydrogen at STP. So STP means standard temperature and pressure. So how many moles means that's where you're going to end, and you're given liters. So start with the number in the problem. 22.4 liters will cancel. Moles goes on top. 100 liters, canceling the units, divided by 22.4 gives you 4.46 moles. So that's how many moles of hydrogen. And the interesting thing, I suppose, is if you had 100 liters of nitrogen gas, you'd also have 4.46 moles. If you had 100 liters of carbon dioxide, it would be still 4.46 moles. It doesn't matter the substance. So to recap here, we did mole conversions. We looked at one-step conversions, going between moles and any other measurement. We also looked at two-step or multi-step, where there's not a direct pathway between the two units you're given in the problem. You got to pass through the mole. So what you need to be able to do as a result of this lecture and our in-class practice, be able to perform any conversion starting from anywhere on the mole calculator and going to any other value. So doing whatever conversions are necessary, canceling the units, putting the numbers in their right place. And as I've said, we're going to do lots of practice with this to get it squared away. But that is it for this lecture, and we'll go over this in class.